Hello student, hi, good evening. So today we are going to see how to find the linearity, non-linearity or LTI. Okay, so whether the system is linear, non-linear, causal, stable or the discrete time system. Okay, so that is by taking one problem. I think you will see rarely this type of problem. Okay, so that I am going to show here. Okay, so this is what, let's say I have one problem. So this is my discrete time system which is given as here y of n is equal to x of n plus 2y of n minus 1. Now what we have to find here? So now we have to check whether the system is linear or non-linear. We have to check the linearity of the system. We have to check the time variant or time invariant property of the system, and also we have to check whether the system is stable or unstable, and we have to check the causality of the system, and also we are going to draw the block diagram for this system. Okay, so that is what. Let us go step by step. First we are going to find here linearity. Okay, linearity of the system. Linearity. Okay, so how to check the linearity of the system? For that, if you see how to check, because you see this is not a non-recursive system. Okay, it is a recursive system. First of all, we have to take the variable, separate variable. Okay, so because here is what, this is recursive system. Okay, we are going to make this what, the non-recursive system. So that is what what we have to do for that. Okay, so before checking the linearity, so let us say first you take this y of n this side. So this side it will come what, minus 2y of n minus 1 is equal to x of n. Okay, x of n, because we have to make the form of y of n is equal to x of n. Okay, so like this. So just then what we have to make this type of function y of n is equal to like some constant x of n. Okay, x of n plus x of n minus n naught. Okay, so like this form we have to make. Okay, so from this, so then it is easy to check the linearity of the system. So then how we can get this one? So first this we can make like by assumption. Let us put here first n is equal to 0 by putting the value of n. Okay, so from 1 to up to somewhat number. Okay, so 1 to 5, then we can guess. Okay, so which form is going to form, which form we are going to obtain. Okay, so by this, so let's say first I'm going to put here y of 0 is equal to what, 2 y of what, minus 1 is equal to what, x of 0. Okay, x of 0. So you see the initial condition is what, 0. So this is my 0. So from here we get what, what we will get, y of 0 is equal to what, y of 0 is equal to x of 0. Okay, so y of 0 is equal to x of 0, that we got for n is equal to 0. Now see, for n is equal to what, for n is equal to 2, n is equal to 1, y of 1 is equal to here 2 y of 0. Okay, so is equal to, okay, so this is minus here, 2 y of 0 is equal to x of 1. Okay, so if you see y of 0 is what, x of 0, so then we can write this as y of 1 is equal to what, this will come this side, so x of 1 plus 2y of what, 0. Okay, so you see this is x of 1 plus 2, not y of 0 is what, y of 0 is x of 0. Okay, so then we can write y of 0 is equal to x of 0. Yes, you see some form is coming like x of n plus 2, x of n minus 1 form is coming. So let us check further. Okay, so if we will check it further, so let's say put here value of what, put here value of n is equal to 2. So if I will put n is equal to 2, then what I will get here, you see, by putting n is equal to 2, so y of 2 is equal to here x of 2, this will come this side and it become 2 y of what, 1. Yes, y of 1. You see y of 1 is equal to what, y of 1, what was y of 1, this x of 1. Yes, just put here y of 1 is equal to x of 1. So then what we will get here, we will get 2x of 1. Yes, similarly if you will put y n is equal to 2, then what we will get, n is equal to, yes, this is what n is equal to 2 we have put. Okay, we have put n is equal to 2. For that we got what? X of 2 plus 2 x of 1. So this means what? We can guess which form is this. Okay, so can you guess which form we are going to obtain? So the form that we are going to obtain is what? X of n plus 2 x of n minus 1. So this is okay. So this is what? Y of n. Y of n is equal to x of n plus 2 x of n minus 1, and this form is what? Non-recursive, and the form was given recursive. Okay, so that is what. First of all, we have to make the recursive form, non-recursive form from the given recursive form. So then it is easy to check the linearity time invariant property of the system. Okay, so that's why this is the reason. I think most really you will get this type of problems. Okay, so like that. So this we have to check like that. Okay, so because this is what recursive form we have made, we have made the non-recursive form from recursive form by putting the value of n in sequence. Then after certain sequence we can guess. Okay, so which form it is obtaining. Okay, so this is what? X of n plus 2 x of n minus 1. Yes, so this is what. Now what we can write finally. So this is the important part only. Now it is easy. Okay, so because now here this we can also write now this y of n is equal to what? Is equal to x of n plus 2 x of n minus 1. Yes, so this is okay. So we can write this system as this. Okay, this discrete time system as this. This is what? This is recursive, and this is what? This is non-recursive. Okay, so that is. Let's see. Now we are going to find what? First, linearity. Okay, so first we will check linearity of the system. Linearity. Okay, so linearity of the system. What is the discrete time system that we have found in non-recursive form? This is x of n plus 2 x of n minus 1. Okay, so this is. Now let's say first y1 of n is equal to x1 of n plus 2 x1 of n minus 1. Okay, so now similarly y2 of n is equal to what? x2 of n plus 2 x2 of n minus 1. Okay, so now similarly y3 of n is equal to what? x3 of n plus 2 x3 of n minus 1. Okay, so now where x3 is what? Where x3 is nothing but here x3 is equal to x3 of n is equal to x1 of n okay, plus x2 of n. Okay, so now we are going to put this x3 of n into this y3 of n. Then we will check, is this y3 of n equal to the sum of this, okay, or not. So let's see. I am going to put this x3 of n into this equation. Okay, so value of this x of n plus x1 of n plus x2 of n. Okay, so for this I am going to rub this. Okay, so and here I am just putting x3 of n is equal to x1 of n plus x2 of n. Okay, so like this. This is what? x1 of n plus x2 of n. Okay, so plus 2 into here x1 of n minus 1 plus x2 of n minus 1. Okay, so this is. Now further x1 of n plus take this to x1 of n minus 1. Okay, so then here x2 of n plus 2 x2 of n minus 1, 2 of n minus 1. So this is what this is my y1 of n, this is my y1 of n, and this is my y2 of n, is it? You see, this part is y1 of n and this part is y2 of n. So therefore I can say that my y3 of n is the sum of y1 of n plus y2 of n. Hence in this way this system is what? Linear. The given system is linear. Okay, so that is what. Now finally what I can say, that the given system is what? Linear. So given system is linear. Okay, so linearity is satisfied here. Okay, so next we are going to find what? Time invariant or time variant. See, time variant or invariant. Time variant or invariant, that we are going to check for this system. Okay, so how to check that? See, first we will take y1 of n is equal to, we are going to shift the input. Okay, so by an amount of n naught, so that we will represent by y1 of n is equal to x n minus n naught plus 2x n minus 1 minus n naught. Okay, so this is my y1 of n. Okay, so now I am going to put n is equal to n naught. Okay, I am going to shift the output by an amount of n naught. Okay, here I have shifted input by an amount of n naught. Now I am going to shift this output. Okay, so this is what y n minus n naught. Y n minus n naught is equal to what? Just put here and put in place of n is equal to n minus n naught. So this is x of n minus n naught plus 2x of n minus n naught minus 1. Okay, so minus 1. Now see here, y1 of n is equal to y n naught, y1 of n is equal to y of n minus n naught. Is it equal? Both equal? Yes. See, x of n minus n naught, x of n minus n naught plus 2x of n minus 1 minus n naught plus 2x of n minus n naught. Both are equal. So now we both are satisfying. Now we can say that y1 of n is equal to y n minus n naught. Y n minus n naught. Hence the system is what? Time invariant, not variant. Yes, my system is time invariant. Okay, so that is what next property that we have satisfied, that the given system is linear and time invariant. Yes, now I can say that the given system is what? Given system is linear time invariant. Yes, this system is what? Linear time invariant system that we have checked. Okay, so this is how we can check the linearity and time invariant property of the recursive system. First we have to make the non-recursive, okay, from the given recursive. Okay, so this is what? Non-recursive, but given was recursive. Okay, so this is what the given system is, linear time invariant system. Now see, now what we are going to see here, now we are going to find the stability of the system, or stability of the system, or which type of filter it is, IIR filter, okay, so FIR filter, like that. So for that, what we are going to see first, this is what we are going to see, the stability of the system. Okay, so this is what the given system was, y of n is equal to x of n here plus 2y of n minus 1. Okay, how we can check the stability of the system? Very easy. Let us take the Laplace transform. Okay, so of the system on both sides, then we can find the stability of the system by drawing the pole zero diagram. So let us take this first. This side, y of n minus 2y of n minus 1 is equal to what? X of n. Okay, now apply the Laplace, apply the z transform. Oh, sorry. Apply the z transform on both sides. So by which we get here y of z with initial condition is what? 0 minus 2 z inverse y of z is equal to what? X of z. Yes. Now see here, y of z 1 minus 2 z inverse is equal to what? X of z. Okay, so now let me rub this first. This is what we got. Okay, so this is y of z into 1 minus 2 z inverse is equal to x of z. Let us remove this also. Now see, we have obtained what? Y of z into 1 minus 2 z inverse, okay, equal to what? X of z. Now see here, transfer function is what? H of z is equal to what? Y of z divided by x of z, which is equal to what? 1 by 1 minus 2 Z inverse. Okay, so this. Now see, draw the pole zero diagram for this system. Okay, so now see how to draw pole zero diagram. This. So this is my, if you see, this is my unit circle. Here pole is present at 2 or not. You see pole is at 2. I can write this as Z divided by Z minus 2. Here one pole, 1 0. 0 is represented at origin and pole is present at 2. So this is my pole. Yes, this is my pole. Pole is what here? Where? Here. This is my pole and this is my 0 here. What is ROC? If you see here, ROC modulus of Z greater than 2. Yes, ROC is what? ROC is modulus of Z greater than 2. This is my ROC. ROC means this outsided. Yes, so this is my ROC. Okay, be careful that ROC never contain pole. Okay, so that is what ROC is outsided. And if you see this is my unit circle. What we are observing, is this system stable? No. Why? Because if you see, this is what unit circle. ROC is what? ROC is out of the outermost pole, and here ROC is not containing what? Unit circle. Yes, ROC is not containing unit circle, so that's why the system is what? Unstable. What? Unstable. So hence we can say that the given system is unstable for ROC modulus of Z greater than 2. The given system is unstable. Yes. So now we can say that what? The given system is unstable because the ROC is lying outsided, okay, out of the unit circle. So which is not containing unit circle, means ROC is not containing unit circle, means this system is what? Unstable. Okay, so now let us find an inverse Z transform of this. What we will get then by finding inverse Z transform? See what we have obtained here. H of Z is equal to 1 by 1 minus 2 Z inverse. Yes, where my ROC is what? Modulus of Z greater than 2. For this impulse response of the system, by applying inverse Z transform, what we will get here? 2 to the power n u of n. Yes, so this is what my impulse response of the system. Yes, is it stable? Not stable. You see why? Because 2 is greater than 1. So greater than 1 means as n increasing, it is increasing. Okay, it is increasing. Okay, so means that t approaches to infinity, this become infinity. So that's why the system is what? Unstable. You see this one here, 0 1 2, and it is increasing. Okay, so as in and increasing up to infinity. So this is so the system is what? Unstable. You see from here only you can see as n varies, then h of n also vary. Yes, so this is what? Unstable. Unstable means what type of filter it is? This is IIR. Okay, so this is what? IIR. From here we can say that this is IIR filter. Okay, so because the pole is present here, wherever the pole is there, it become IIR. Okay, so infinite impulse response. Okay, so now we have checked the linearity, we have checked the time invariant property, we have checked the causality. Yes, the system is also causal because as you have seen that the ROC is out of the outermost pole, so the system is what? Stable. System is what? System is causal but unstable. Okay, so because the ROC was not containing the unit circle. So in this way, and also by finding the impulse response from here, we can say that the system is what? IIR system. Okay, infinite impulse response. Okay, so this is what, in this way we can find all the property of the system and stability, causality. Okay, so how we can draw the block diagram for this also? Let's see the block diagram also for this. So as we have obtained this one minus 2 Z inverse. Okay, so how we will find here? This is what? Feedback. Okay, so forward path gain is what? Unity. You see this is my summer. Okay, so this is my forward path gain with what? one gain. Here is what? My input, what? X of n, and here is my output, y of n, and here I am going to apply what? Feedback with one delay. So this is Z inverse. Okay, so with gain of what? With gain of 2. Okay, so this is going to be here my feedback. This is my gain. Okay, so this is what? The block diagram. So this is positive. This is the block diagram for this given recursive system. Okay, so everything we have obtained, everything we have explained. Okay, so I have explained everything: linearity, causality, stability, infinite impulse response, IIR filter. Okay, so and also the block diagram for the system. Okay, so this is everything about the given system that was what, recursive. This system y of n is equal to what, x of n plus 2 y of n minus 1. Okay, so the system is what, LTI, that we have obtained. The given system is LTI system. Yes, correct. Next, given system is what, causal. Given system is causal, correct. Given system is what, unstable, not stable. Given system is stable, wrong, it is unstable. Given system is unstable. Causal unstable LTI system. And also it is which type of filter? IIR filter. Given system is IIR filter. So this is all about the discrete time system. Okay, so anything can come. Okay, so because the most important was like how to find the linear time invariant property for this recursive type of system. Okay, so main important point was here, that was we have to first convert the given recursive system to non-recursive system. That was the most important point. Okay, so after that everything was easy, so not so tough. Okay, so that is what, because the problem will come here while finding the linearity of the system and time invariant property of the system. Okay, so because if you will see like this, so that's why by putting the value of n, okay, so we then after certain sequence, then we can detect, okay, so we can guess which type of form which type of form we are going to obtain. Okay, so in non-recursive type of system, so then after that it becomes easy. So that's all for today for this discrete time system. Thank you very much. Thank you.